Awesome.
So thank you everyone for coming to the event tonight. This is our IBM Data Analyst Q&A with Precious Chima. And if you could please introduce yourself, Precious.
Awesome. Well, thanks everyone for taking the time to make it today. Also, huge thanks for having me, as well as to you, Vivian, as well, for your efforts in setting this up, making this happen. As you all know, I have a bachelor's, as you all more probably know, I have a bachelor's in AMS from Stony Brook. I also minored in mechanical engineering. It was my major for most of my Stony Brook career, actually. So I have a strong background in mechanical engineering. Currently, I'm a customer success manager, solutions architect, inventor, and data scientist, working within the US communications and computer systems integrations market at IBM. And prior to taking on this role, I was also a member of the Cloud Pack acceleration team here at IBM, where I helped clients in various industries from healthcare, automotive, government to accelerate their digital transformation through cloud adoption. I'm also the founder of Strictly by the Numbers, LLC, which is a data and AI platform for everything basketball. Whether that's predicting the next MVP, optimizing coaching strategies, settling the most polarizing basketball debates, strictly aims to creatively address some of the most challenging problems faced by coaches, NBA general managers, players globally within the game of basketball. And you can check out some of my work at www.strictlybythenumbers.com. And that's just a side project that I do. I would say that my expertise lie within the space of machine learning, deep learning, specifically natural language processing and computer vision, big data and microservices. So anything with Docker containers, Kubernetes, etc. And prior to joining IBM, I worked actually in the Middle East in oil and gas industry, where I specialized in hydraulic and mechanical parametric optimizations on drill bits to improve drilling performances. On a more personal level, I'm married with a son. He's 4 months old. I'm currently taking care of him while that's why I don't have my camera. I'm carrying him while talking here. And during my spare time, I enjoy exercising, reading, watching, and playing basketball. But also inventing is something that I do a lot when I'm free. So that's me in a nutshell.
Yeah, thank you for the introduction. I guess we can get started with some of the questions that people submitted. So we know you did your bachelor's at Stony Brook. People were wondering, what AMS courses did you take that prepared you most for the data science field?
Yeah, so this is a pretty tough one to answer, just simply because I can't really attribute my preparation to one AMS course. I really do feel like all the AMS courses almost hold equal weight in some regard, because data science as a field can be very, very, very spread out. And some people might choose to be generalists or specialists. You know, some people might work at companies where they're just doing all computer vision applications. And in that case, certain math topics might be more relevant there as far as thriving in that space. For example, like how well versed you are with linear algebra, matrices, and whatnot is always more beneficial with deep learning. It's beneficial everywhere, but with deep learning and dealing with tensors and arrays, being good at linear algebra and understanding those concepts in the depth, because they really do teach it at the 100 level in undergraduate, at least from what I remember when I was at Stony Brook. And a lot of these concepts can be very abstract to people and not relevant in that moment. But once you start dealing with deep learning, you start to kind of get this deja vu feeling of things that you've heard before but couldn't really connect the dots together. And so, yeah, so to answer your question, it's really just depends on what specialty you go into, but I would take every single AMS course seriously, because I would say they're just inextricably correlated as far as importance. Yeah.
Okay, that's good to know. Would you say you used anything from college on the job, or did you learn a lot of the things while you were working?
As far as if you want to look at it from a pure technology perspective, I've learned a lot of most of the technologies from working because I learned programming on my own and didn't really do I didn't do programming at all professionally when I started my career. I worked in oil and gas, which is a very archaic industry. You're wearing coveralls. You're going in the middle of nowhere. It's a very different nature of work. So I wouldn't really say that I would say that I learned the tools there, but as far as the core concepts which stuck with me from AMS, I feel like that's what's allowed me to thrive. You know, being able to look at a new algorithm, for example, and uh, quickly be able to know how to, like, you know, modify the algorithm, how the algorithm could be useful in specific business use case. And I feel like a lot of data scientists, even with experience, I've met a lot of people with experience that can't do that because they don't have the in-depth math knowledge. And so to me, really all the courses I took at Stony Brook and the mathematical understanding that I gained there set me up to be able to learn all the concepts that I need um, in data science. And even till today, whenever I'm tasked with new projects, I don't always know everything. You know, I got one of the projects that I worked on when I first came to IBM is a project that that's actually deployed at Geisinger, which is a healthcare institution. And I had no idea how to do what is it, censorship modeling. I can't remember what it was, but it's pretty much so sorry, I just remember, sorry about that. Survival modeling has been so long. So there's so many survival models which I'm very well versed at now, but at the time when I took on this project, which is one of my biggest impact, one of the projects that I felt like I impacted the most, I didn't know anything about survival models, but I was still able to read about survival models and read about the theories, go deep into the proofs, and actually understand it very quickly in a way where I was able to actually execute on a solution that had a business impact. And I think that's really more so the skill that you're going to be looking for, because the reality is there's so much to learn, and you would almost never remember anything, especially when you start diving into more esoteric topics that are expected of a data scientist, but are not within what you would traditionally think of when you think of a data scientist. For example, like I do a lot of stuff related to architecture right now, and most people don't like, a lot of data scientists don't like it, and so yeah, so that's the reason why I would say that.
Okay.
Yeah.
We have a question in the chat. Did you do research as an undergraduate? And if yes, which professors were your advisor?
No, I didn't do research as an undergraduate, but I know the closest professors that at least the ones that I lean to for a lot of my advice, were really three professors. It was one professor from data analysis. I don't know if he's still at Stony Brook. His last name is Finch. I forgot his first name.
Yes.
He teaches AMS 315, I believe.
Yeah, I took that class last semester.
Yeah, so he was great. He gave me a lot of advice during my time there. And then I took a class. My favorite class at Stony Brook during AMS was 342, which is stochastic processes still today. And I use it for a lot of, I would say, time series related modeling work that I do. And it could be out of scope for a lot of people in the industry, but it's a very interesting course. So the teacher for that course is, I would say, he's number 2/3, and then definitely SD Arkin. She's a tough one, but she always gave me great advice every single time. So those three.
Yeah, SD's still here too.
Yeah.
Do you remember who taught the stochastics course?
Stochastics 1 was taught, which is deterministic models, was taught by SD. And Stochastics 2 is the one I'm talking about, which is stochastics. Well, stochastics. Sorry, the first one was not stochastic. The first one was deterministic. So the stochastic was taught by, wait, who is it taught by right now? I can't remember his name.
I'm not sure.
Man, oh man, sorry. Stochastics. I can get this back to you though. It's a skip in my head. It might be the same teacher, but
Okay.
I can get back. I can get back to you if you send me a, if you ping me later on with this. I'll get it back to you. Yeah.
Okay. Well, we can move on to a different question. Darren asks, why did you ultimately choose to leave mechanical engineering? Is that?
Good question. Oh well, I would say that I always wanted to leave. I always wanted to leave mechanical engineering since my freshman year at college. I just couldn't. It wasn't that easy. I come from a background where most of my family members worked in oil and gas, and I grew up in Saudi Arabia, in Saudi Aramco specifically. And so for me, I always had some sort of pressure to go in the oil and gas realm. And being good at math in high school, my dad thought it was great for me to go into engineering. And from the beginning, I knew I didn't like it. I knew what I was good at. I knew what I was passionate about, which was always math. And there was, to me, there's a clear difference. And to most of you guys, you would agree. But my dad, he was kind of archaic with his thinking. And so I kind of rode that out for a few years. And eventually, I decided to drop it, despite completing all the classes but one, and switch to AMS, which is really what made me happy. And so when I went into the industry, I was really more so trying to meet a financial goal at the time with an open heart. I would really wanted to love what I was doing, but I guess what I really wanted to do was knocking at the door. You know, they say whatever resists persists. So eventually I had to quit and leave, but that's the story behind it.
Interesting. Okay. One more question about education, but I'm not sure if you got your master's, but do you think it's required for your data science? And did you get your master's personally?
No, I did not get my master's, and I don't know if I will. But to answer your question, I would say I can't say no, and I would say I can't say no or yes, but if I were to choose one, I would most likely say no. If you said a PhD, then it might be a slightly different discussion. I do feel like the marginal difference between a master's being a one-year program doesn't really like separate you as a thinker or as a mathematician in general, because I do, a lot of my colleagues got their masters, and a lot of the colleagues that would still lean on me for solutions or thinking processes during undergraduate still would ask me after they got their masters in either AMS or data science the same questions, and I didn't get my master's. So I feel like that 1 year doesn't really make that exponential difference. But at the same time, everybody's different, you know. So you could enroll in the masters, and you know, 1 or 2 courses could be what makes the big difference for you. You know, for me, I could say that I mentioned 3 courses. From all the courses that I took at Stony Brook, I would say those 3 courses are they're probably the most pivotal courses for me outside of probability theory, which is my second favorite class of all time, probability theory. So no, but I don't want to knock it. I don't want to knock people's ambitions down, because you know what impacts every individual is different, and some people might need to go to their masters, but I don't really think it's necessary to impact. And the same thing applies for people who are getting their master's or PhD in computer science. So one thing that I've observed in the industry is that you can also see people that have PhDs in computer science that can essentially code anything that you can think of, but that doesn't mean you can still impact a project. A project is based on business outcomes. So if I have a problem where I have like a data set with like 5 million missing rows, and all you can do is write code, that doesn't solve my problem. It's like, how do I creatively fill in these missing values in a way where the underlying distribution is still the same as what it would represent in the real world. So that way, when I create a model, it's actually robust and generalizes to unseen cases. How do I do that? And a lot of I've been on projects where people post this impressive backgrounds. They go to all these great colleges, they have PhDs, they have all these things behind their belts, but when they're on these projects, they can't creatively think about a way to solve these problems that actually impact the business solution. And so to me, that's why the answer could be yes or no, and it could be no, not only to the math, but also especially to computer science, because I think nowadays we get lost in just the ability to code. It's great to code, but I would argue that your conceptual understanding supersedes your coding abilities, because you can impact projects with your ideas and your innovation and your creativeness without actually being able to code at all. Because guess what? You can have a million coders who can write anything. If you don't have that idea, there's nothing to code, right? So,
Yeah,
that's how I look at it. That's how I look at it. And also, the last thing is, for me, I always feel like if I have a conversation with somebody for, like, let's say an hour on just, like, math and data science and topics, related topics, I'll be able to quickly know if they're qualified for whatever role that I might need, as opposed to testing how well they can code up an algorithm in general. And I guess the last thing to hammer that home is, really, if you think about it, scikit-learn and all these packages like TensorFlow, they all have all these things built in them. So when you fit a linear model, you don't really need to understand a linear model, but it's like, can you really explain how this beta coefficients work? Can you really explain how regularization works? How the L2 norm works? I'm saying all these things are really what's going to tell me what you really know, not whether or not you can code up a solution, because guess what? Packages are making this thing so much easier, and you're not separating yourself when you just really focus on those skills and not really your core conceptual understanding of the algorithms and the math and how they can be leveraged in specific scenarios to address business problems.
Yeah, that was a really good perspective. So I guess your problem solving ability would be more valued than like how much you know how to code.
I believe so, and I would say it's a personal opinion, but I firmly believe so. In fact, when I was interviewing for jobs, I spent very, very little time working on anything code related. I spent 80 to 90% of my efforts perfecting every single algorithm that exists within data science and machine learning, being able to explain it in different levels. So if you run into someone like me, how can you deliver an eloquent explanation to that model? If you run into someone that's not that technical, how can you still demonstrate your technical depth but still make it easy for someone to understand? I'm saying these are the things that I worked on, because those things would communicate what I was capable of, more so than whether or not I got a coding solution correct. And to be quite honest, there's been a few coding interviews that I've taken part of, which I failed. But I still passed. I still passed the interview because of that, right? It's not always about the coding. So, and two of them were at the FANGs companies that I was, you would think that you'd fail, but you pass if you're able to really give people a more transparency into, like, how far your creativity goes and how far your depth of these algorithms that are just far beyond just doing like a linear model fit on some computer software, and you're really truly understanding how they work.
Yeah, that's really good to know. I kind of wanted to transition more into like your career path.
Sure.
So some students asked, could you define exactly what a data scientist is, and what is the difference between a data scientist and a data analyst?
That's a tough one. So I would say, like, the difference between, I always view data scientists, data analysts as people who manipulate data. It's more so like you could view it as the EDA type of phase. You can, whether you're writing SQL queries or you're writing Python queries, you're just like more so manipulating the data, as opposed to like how do I say it? Building predictive models. So that's how I'll separate a data scientist from a data analyst. But once you start talking about how do we separate data scientists from machine learning engineers, from machine learning engineers, that's a little bit tricky, because it's and the same thing applies for data analysts, not as much, because every company defines it differently. I have friends that work as quote unquote data analysts, but they're full stack developers. Like they're much better than me at everything that I do. They can design everything, and their titles are data analysts, but their expectation at work is to do stuff that a full stack developer would do, which is not, to me, I think that sucks, because you're almost like downgraded from the outward perspective, right? And then there are people like, at IBM, let me not say IBM, because IBM is a big organization, right? With 350,000 plus people globally. So the organization that I was part of at IBM, sorry, my son is crying. Why are you crying? He's trying to sleep, sorry about that.
No, that's fine.
But at IBM, the expectation of a data scientist is very different, right? So like for me, when I came in, I thought I was gonna just build models. I'm here, let's just build models and fit models. No, that's not what I was doing. I was working on infrastructure, architecture, microservices, things that are more important from a business perspective, because a lot of times clients are not, most organizations are not at a stage where they could start building models. Most companies are not modernized. So a lot of times people are facing infrastructural issues. They're facing data issues. And so having those skills are usually very, very pivotal from a business perspective when it comes to even getting to the modeling steps. So if you think you're gonna just hop on a project and build fit models, a lot of times you won't, because unless you're just, that guy or girl, which most of the times you won't be, it's okay. Just having, I guess, more broad skill sets are what I would advise to people with time. Don't rush it, but try to broaden your skill sets, because you have to think in terms of business. Most businesses are not ready for AI. So yeah, you can have opportunities where you could implement some AI solutions that are going to be very, very beneficial. But at the same time, having these other skills makes you more high value as a candidate, simply because first off, they're all intertwined, right? All the things that I know in DevOps apply directly to data science. I would just say it makes you a more high level data scientist. But at the same time, it gives me opportunities to do data science, which I like, simply because I get to be involved and engaged with customers before they get to the data science. So selling them the software, making sure their software is installed, making sure there's what's it called? How do I say it? Make sure the software is installed, making sure it kind of fits within the business context properly, and then seeing, okay, how can we properly position these people where we can use AI to improve whatever they're already doing, right? And so that's usually where it starts. So I don't know if I answered your question.
I hope you guys understood. I think it did answer the question.
Okay, awesome. Feel free to ask me follow-up questions. I'm sorry, my son is like making a bunch of noise.
No, it's fine.
Yeah, it's fine. Okay, give me a second. Okay. You can ask the next question. I'm just gonna get him a bottle. Okay. I can hear you, by the way. I'm wearing Bluetooth headphones. I just gotta get him some food.
Okay. He doesn't like data science. Okay. We can ask, okay. Mahan asks, how did your journey to IBM start, and was it difficult to get into IBM? could you give like the interview process that you went through and like how you prepared to interview for IBM?
Yeah, so I think it's always you definitely have to. The first thing I would say is lean on your math skills. You know, a lot of people are so caught up in the whole data science and coding and all of that that they forget that there's an added edge in knowing math in depth. I think that's the first thing. Lean on your math skills, and then lean on your past experiences. Don't think anything that you've done in the past is a waste, because I used to always think like that and think like, oh, I've never worked in this industry, I've never coded, never done all this stuff. I mean, how do I show someone that I'm worth this positions, right? And but then when I figured out my story, know your story, like memorize your story, you know, be ready to tell your story and be ready to show people how the things that you've done in the past, whether related or unrelated, can be leveraged into what you plan to do in the future. And so like a lot of times that's what I was doing. I was trying to tell people why the 3 years that I worked in a different industry that was so different, I mean, a different industry, how my experience wasn't a waste. How is this beneficial in transitioning? I think that's something that I leaned on. And then the third thing, as far as like landing these jobs, for me, I always said is having great projects. You know, I always say projects always tell the most about people. You can have all these things on your resume, but what you've done tangibly is people can relate the most to it. So when I was interviewing, I always had projects in which people could not only see on my resume and have hyperlinks ready, but when they hit those hyperlinks, they see something visual. You know, it could be a machine, it's usually a machine learning project, but there's always a visual and there's always a business case behind it. So I would never talk about a machine learning project and tell you, oh, I did this transformation to clean up this column and all this technical detail that are extraneous, right? I would never do that. You know, I'll always show you a clean, simple diagram. There might be a lot of complexity in the background that's being abstracted away, right? But the idea here is for you to present this to a business stakeholder in a way where they see that you've done a project that impacts a business decision properly. And that to me is really might be the biggest key takeaway from this, because people always like to tell me about the complex things they know, the complex things they have done. But a lot of times the most elegant solutions are simple. That's why they're hard to think about. So a lot of times these projects that you do don't have to be hard or complex. And the one that I created when I was interviewing was very simple. It took me 2 days. But it had the greatest impact on my entire interview process, and it really was the birth of Strictly by the Numbers. You know, I created a side project that wasn't on Strictly by the Numbers, and it led to me creating Strictly by the Numbers, which, like, if you go on there now, you can see the whole platform I've been building for a year. But I would say that's the biggest thing that people should lean on, having these projects that have business cases. But from a resume standpoint, interviewing standpoint, you want to have them linked on your resume, but when someone clicks that link, they should be able to land on a page that's visual, where all the complexity has been somewhat abstracted from them. So that way you, as the subject matter expert, when you're explaining these projects, you're gonna really be talking more so from a business perspective. Maybe here and there, depending on who you're talking to, you might, you know, let them into some of the technical details as the expert, but your goal is for them to understand what's going on, right? And to see what you've done, how you did it, and what the results were. And so those were the main things. As far as the approach, I mostly cold emailed people because for me personally, the probability was much higher. You could apply to 500 jobs and do the math, right? And see what your conversion rate is with a lot of AI algorithms that are in place nowadays to handle like the first round check. It's very low. But I realized that with my cold emails, obviously you have to craft your cold email in a way. You have to find what works for you. But just from cold emailing, I was able to figure out the right email that was short enough, had all the things in it, all the right substances in it, and I would just send people inboxes, whether it's LinkedIn, whether it's cold email. A lot of times on LinkedIn, but on LinkedIn I tend to try to message. Back then I would try to message people that were probably LinkedIn Premium, that had LinkedIn Premium, and I can send them an email because people are less likely. I barely read my LinkedIn messages because I get so many every day. Like a lot of times I feel bad reading one message over the other because I don't see it. Sometimes I don't know why I should read one message over someone, because a lot of people that message me, I don't know them. So like for me, if I receive an email to my email, I'm gonna open it. And a lot of people, especially recruiters, are like the same. So if you send them an inbox, they probably won't open it or read it because everyone's doing that. But if they see a message in their email, then a lot of times they will. And so to me, using that email feature, which doesn't tell you their email, but it directs the message to the email, can really save you a lot. And I got a lot of conversion that way. And in that message, I would have like all the things that I said that are important. It would have my project link. It was very short, very quick, and trust me, the conversion rate was ridiculous, and the people in which I got to place me at places, not at IBM. At IBM, I got reached out to, but I've been placed at so many places. I had like over 10 interviews at Facebook in the past. I've had interviews everywhere. Just 99% of them were off cold emails, and they always worked. But a lot of times, these things will work only if you're prepared. You got to be prepared. I mean, you have to have your resume ready. Your profile has to be ready. Your project's got to be ready, because it's like it's that small opportunity, right? All you need is for someone to respond, and your foot is in the door, And in fact, the two offers that I got at Facebook, I never applied. I never officially filled out an application, and I got an offer. So that's why it's really important to have your projects. Projects are so important, and then your story, the story that you have behind who you are and the impact that you can make. And don't undermine anything you've done. I see so many people with great accomplishments, and they come to me and they ask me for career advice. And sometimes I kind of laugh internally, because I just feel like if I had the same background as them, I could have leveraged so much more. They think so little of themselves. And I think that you have to start, I don't want to say be delusional, but there is some level of delusion that comes with being able to get to there. That it's important, So just wanted to put that out there.
Yeah, no, that was really good advice.
Yeah.
And I'm glad you responded to my LinkedIn message.
You're welcome.
Okay. Also, regarding your projects, were they completely personal, or did you use data sets from websites like Kaggle and things like that? And also, did you use a specific language for your projects?
So I didn't really use an open source. I won't say I use open source data sets. So from a lot of my projects, what I did is I actually wrote. I'll write the code to collect my data. So a lot of times it would be like a web scraper that would go to a website and crawl whatever I need. It could be text information, it could be numbers, and a lot of times I'm taking data from multiple sources. So I think what you just mentioned brings up a good thing that I should touch on, which is like the complexity. By complexity, I don't mean how difficult. I really mean like how horizontally you stretch as far as technologies and like things that you apply within that project. So if you're collecting data, you could use data from Kaggle, as you know, but collecting data from multiple sources says a lot. Like if you show me your resume, it says I collected data from multiple sources. That is like 2 levels higher than just collecting data, even with the same analysis, because just integrating that data together is difficult. Imagine joining basketball data, right, from Basketball Reference and then from NBA.com. They were generated independently. Yeah, they might have the same data, but maybe the way they spelled the name might be different, right? I can be like J.R. Smith, but then the other website might say something like this full name, Smith. So now when you want to join those two tables, you're going to get duplicate roles, or you're going to have incorrect information. The data integrity is going to be missing. So you as a data scientist have to create those custom functions that are going to allow you to integrate data from different sources where they behave like one. So like, just keeping those small little details in mind, like create a project with where I'm pulling data from multiple sources, maybe pulling one from a SQL database, pulling one from a cloud store, something like that. But going back to your question, which is the languages, I did most of them in Python, but currently my projects use whatever is needed to get it done. Like strict about a numbers, two of the routes are built with Python, and then the rest are built with JavaScript. And I used a bunch of cloud technologies. The data is hosted. We have like 300 tables hosted on Google Cloud on BigQuery, and then we have a bunch of like the pictures and the logos and all that stuff is hosted in Cloud Object Storage. So we do a lot of shell stuff as well. So I write a lot of shell scripts too as well. So yeah, I wouldn't even say the language. The language doesn't even matter. It's just really the outcome. Because even when you go on strictly by the numbers, if you go on one of our pages, the one that's built with JavaScript versus the one that's built with Python, a lot of times what you see on the page doesn't really matter, because what the app is taking is just the data that's been already processed from our database and rendering it, right? And so the tool that was used to do all the dirty work has been abstracted away.
Yeah, thank you for your response to that. Another question that was very common was, what does your average day look like, and what does working day to day look like for you?
Yeah, you actually asked me that before. Sorry, I missed it. So the day to day is so ever since I came to IBM, I've really worked as a consultant, even though like I'm a data scientist, solutions architect, and customer success manager. Every role that I've worked at the company has been customer facing. So I've always dealt directly with client. Almost every day currently, I talk to clients, whether it's an executive at a different company or someone from procurement, just communicating and improving the relationships that I had, improving like the relationship with the IBM's clients. Well, in this case, it would be like the accounts that I'm responsible for, and ensuring that we're able to grow on those accounts. And so most of my days are just consist of like, I would say, holding these meetings and making sure they don't have any blockers. There's not really much technical stuff that I'm doing directly in front of the customer. A lot of that stuff is done behind closed doors, unless I'm doing like a POC or like a POC or like a very short demo of like a certain solution. Like very quickly, I might share my screen and show them how to use something. But generally speaking, I'd like to think of my work as more so like relationship building. It's it's more challenging than just writing the code, because a lot of times it's the same as being in a normal relationship, whether it's a friendship or with your parents or with your significant other. It's just the same as far as like, it's hard to build a relationship and it's easy to break. So
yeah.
So those are the things that I deal with on a day-to-day basis. I do spend some time building internal assets. Like I've done some stuff for Pearson, the publisher, like created some data science courses that they're going to publish soon. I also create internal solutions for internal solutions. For example, like we built a chatbot that helps answer 60,000 questions for new hires for under $15 in 2 months.
Wow.
And so this was a AI powered chatbot that I worked with a few people to build. And it was deployed in Slack channels where people log on every day. And instead of like tasking HR with 60,000 questions in 2 months because they hired so many people, you can answer, and the chatbot is able to answer 90% of these questions without needing and the questions that he can't answer, he reroutes it to the human being. So building internal assets, learning, and then the customer facing work, which is what I would summarize as relationship building.
Okay. Yeah.
Yep.
Chatbot sounds really cool. Another question we got was, are there any particular internships or experiences you think that people should try for if they want to break into data science? Or do you think it's more valuable to have your own projects?
You can have internships. I mean, if you can get an internship, it'll be definitely great. I think projects is whether or not you have an internship, it's still important to have projects and always do projects. I know companies that would always ask me about my projects being independent of school and also being evolving, as in they want to see that I'm always doing something, right? I'm not just here to get a job. This is something that I do. So yeah, I would say internship is good, but the projects are ubiquitous whether or not you have an internship, in my opinion.
Okay. We have a question for fun. What's your favorite NBA team?
Brooklyn Nets. I'm a Brooklyn Nets season ticket holder. Favorite player is Kevin Durant. I wouldn't say I'm not a Brooklyn Nets fan. I'm a Kevin Durant fan. Let me clarify that. But I'm now a Brooklyn fan because I do live in New York, and Kevin Durant is now here, and I'm a season ticket holder at the Nets. So
Okay.
Brooklyn Nets.
Alyssa asks, if you feel comfortable answering this, did you negotiate your salary?
No, I did not. And the reason why, and it's kind of why I always tell people to focus on the math. When I got hired, I mean, this is not what I get paid because I'm not really this is I guess a little bit personal. I'm not too private about pay as much as some people, but I guess for type of conversation I can filter out some of the information but still give you guys some good insight. So when I initially interviewed, I had asked the recruiter clearly about the salary expectations because that's really, really important. And it was a junior role. I think that's the title they reached out to me was like a junior data scientist. That's what it was actually called, junior data scientist. And it was around 100K. That was like what they were gonna pay, but it could be up to 135K depending on how well you perform, like bonuses, etc. But based on my interview process, because of I felt like my IBM interview was honestly my best interview. It was my hardest interview, but it was the best interview that I felt like I performed. Like I just felt good that day. A lot of things were clicking, right? So we all have those days where things are good. Yeah. It was my good day, and I think because of that day, it changed everything. I got once I finished my interview, my 6 interviews that I had, I got an offer that was closer to the almost double. It was closer to 200. That's not what I get paid now because I switched organization. So I can't really talk about that too much, but just so you guys know, focus on your math skills, your tangible skills, and also your communication skills, how you can sell yourself, and don't worry about that pay because a lot of times that will take care of itself. And a lot of people might have a different theory, like negotiate all the time, but you might get a lot more than what you probably expected. And for me, that was the case, and I didn't feel the need to negotiate at all.
Yeah, that's really good to know. Another question that we have was, what advice would you give to your college or to your younger self?
If I was in college, I'll definitely tell myself to to work on code, but that's because that's a more personal thing because I was very invested in math. Like a lot of people get the AMS degree, but I really do love AMS. Like I used to be into the proofs. I used to be into all of that. So for me, learning math was like a nonstop journey for me. So like learning how to code, I don't know how the Stony Brook curriculum was, but I did give ST Arkin quite harsh feedback before I graduated about the fact that there was no coding in the curriculum and I didn't have all that stuff ready. But yeah, being able to code at that was going to be the most important for me, the Stony Brook curriculum, because I felt like it was the gap in being able to take what was theoretical and make it practical, because you can actually, the coding is how you execute the math, right?
Mm-hmm.
So you can know all this math, and if you can't write code, you can't execute it. I explained the reverse case whereby someone can write whatever code, but they don't know the theory. Well, there's a dilemma in the other way around too, where you know the math, but you can't write the code. So that kind of dilemma, and I would focus on that. But everyone's different. I met some guys that won the New York City hackathon, even at Stony Brook freshman year. So they might need to focus on something different.
Yeah. Okay. Is there any literature you recommend to focus on relevant to data science algorithms?
The master algorithm, it's written by Pedro Domingos. I mean, that's the only one that comes to mind right away. If you want to just talk about strictly data science, it's called the master algorithm. And then it's more, it's literature, I guess, if you don't want to talk literature. But if you want to talk just like books, then I will say if you were to only buy one book to help you with machine learning, data science, from a theoretical and a practical perspective, as in writing codes, I think there's no one book on the market that's better, especially from for a beginner to advanced, than hands-on machine learning with scikit-learn, Keras, and TensorFlow. Second edition. I'm actually friends with the guy. Not friends, but I would say acquaintances with the guy who wrote this book.
Okay, I think I put the title in the chat. I think it's that one.
Awesome. Hands-on machine learning with scikit-learn, Keras, and TensorFlow. Second edition. You should get the second edition for sure, or else your code is not gonna work. So some things are not gonna run.
I guess one more question we had was,
sure.
What are some common misconceptions you've had to deal with as a data scientist regarding your role?
That I know everything. I still deal with that right now. Whenever I go on projects, people assume that I can do everything because I'm a data scientist, and that can be overwhelming because a lot of times they expect you to have the technical capabilities of any technical expert in that field, but also that separates it from a lot of these technical disciplines is that the level of expectation when it comes to communication skills, especially verbal skills, are very high. They expect very, very high verbal communication skills, and that is very, very difficult because how would I best say it? But we can't be a master of everything, and being able to be great technically and also that eloquent is definitely not something that anyone can do. But when people hear that you're a data scientist, that a lot of times is the expectation. But it's also why I really emphasize to people to really work on these communication skills, because a lot of roles that are going to be very, very beneficial to you in your career are probably going to be customer facing, in my opinion. I really do. Because, you know, everything comes down to business. You can do whatever you want with models, but if it's not making money, it's nothing but a technical solution, solution. So yeah, being able to do everything is a misconception. And sometimes it's, you know, maybe working on a story on what people can expect from you might be a good thing, so you don't get drowned on projects they put you on.
Yeah, definitely good advice. Does anyone else have any last minute questions? If not, we could probably end a little bit early.
Awesome. Well, I know I mentioned earlier that I'll take the resumes. I don't know if you had those. If you do, just forward the resumes of people who attended to me, I guess, after this meeting, and I'll take a look at them. And if there are fits, I will send the individuals respectively like a referral link, which they could use to apply for roles that I feel like fit their resume and skill sets. And if they feel like they're qualified for certain roles, they should also send me an inbox, and I will also take a look at that and see how it matches against their resumes as well. So
yeah, thank you.
No.
Alyssa asks, when do companies start hiring?
I would say I'm not the expert on this, to be honest. So, but I would say that obviously they hire 365 days of the year, but I would say from around now until December is a pretty prime time. Is one of the hiring peaks, I would say. There's another one, but I'm not sure. I don't remember off the top of my head. But this is definitely one of the peak times for hiring. Sure, and you want to target those times if you can, because they're always the easiest times to get the highest value of your skills.
Yeah. To add on to that, I think right now until usually during the fall semester is recruiting season. So companies will typically start hiring now for next year. So you guys should start applying early if you're thinking about certain roles. And there's definitely opportunities now.
Yeah.
Does anyone else have any other questions?
Awesome. Well, thank you so much, Vivian. I really, really appreciate you setting this up.
Yeah, of course. Thank you so much for being here tonight.
Of course. And then, yeah, just we'll talk offline after this. And thank you guys for really making the time to attend. Hope you guys learned something or got something out of this some way.
Yeah, thank you guys. Have a good night.
Good night. Take care. Bye-bye.
Bye.